Now, let us learn about image formation in spherical mirrors. Okay, so in the today's morning class, we have been studied about the formation of images in spherical mirror. Okay, so that we know that if the position of the object is changing, then the position of image formed will change according to the incident ray and the reflection of the light ray. Okay, so that according to the position of the object as well as the position of image formed, we can classify them according to various size, shape, okay, of the images, and also there is a particular nature for the image. That means if the image is formed behind the mirror, then it will be a virtual image, and if the image is forming in front of the mirror, then we call it as real image. So in this table it has been given that when we place the object at infinity, beyond C, at C, then between C and F, then at F and between P and F. So, position of object is changing, so that you can see as the position of image also changing. The position of image formed also changing. And you can see there are different size of the image. Okay, some of the images are highly diminished and point sized, some are say of same size, and some are enlarged image. Okay, some are highly enlarged. Okay, you can see that. And also when we consider the nature of the image also, there is the formation of real and inverted image. And also when we place between P and F, P means pole and F is the principal focus. Okay, it is virtual and erect is formed. So what that is one difference in the case of concave mirror. Okay, so that here what C here, C means center of curvature. Okay, so you don't forget the terms and all. Now let us look to different rules for drawing this ray diagram for identifying the position of image. Rule 1. Ray parallel to principal axis will pass through the focus after reflection. That means when we consider the concave mirror, you can see that this is the incident ray and it is hitting on the mirror and it is reflected back through the principal focus. Okay, that means if the incident ray is parallel to the principal axis, this is the principal axis, and if the incident ray is parallel to the principal axis, then is reflected back through the principal focus. Okay, this is the principal focus, so it is reflected back through the principal focus. Similarly, in the case of convex mirror also, the ray is incidenting parallel to the principal axis, so that it will pass through the principal focus. Okay, you can see that then it is reflecting back. Okay, it is passed through the principal focus and has been reflected back. Okay, similarly, moving to the second rule. Ray passing through focus will become parallel to principal axis after reflection. That means here you can see the ray is coming through the principal focus, so that the reflected ray will be parallel to the principal axis. This is the principal axis, and if the ray is passing through the principal focus, then it will be reflected back in a parallel manner to the principal axis. Similarly, you can see that the ray is coming here. So, okay, it will move through the principal focus. It will move through the principal focus, so that the reflected ray will be parallel to the principal axis. This is the principal axis, so that the reflected ray is parallel to principal axis. This is the second rule. Now we can move to the third rule for drawing the ray diagram. Okay, so that in the third rule, ray passing through center of curvature will follow the same path back after reflection. That means if the incident ray is passing through the center of curvature. Okay, this is the center of curvature C, and if the ray is passing through the center of curvature, then we can say that it will reflect back through the same position. Okay, if the ray is passing through the center of curvature, it will be reflected through the center of curvature itself. Okay, so that in the case of convex mirror, this is the convex mirror. So when a light ray is passing through the convex mirror, it passes to the center of curvature. It is reflected back through the center of curvature itself. Okay, so it is the reflection of the ray. Okay, now we can move to the rule number 4. Okay, in the rule number 4, you can see that ray incident at the pole is reflected back, making same angle with principal axis. That means if the ray is hitting at the pole means the end of the principal axis. That means it is the middle of the concave mirror. This is the aperture and this is the middle portion, that is known as pole. So that if the ray is incidenting at the pole, then it is reflected back with the same angle. Here in the case of convex mirror also you can see it is hitting at the pole, it will be reflected back with the same angle. Here you can see this principal axis will act as a normal line and incident angle will be equal to refracted angle. This is the angle you can see. Here also the same is taking place. So these are the 4 rules for drawing the ray diagram. By using this we can draw the ray diagram. Okay, by observing these laws. So, first of all, we can look at the image formation in concave mirror. Okay, image formation in concave mirror. So, here you can see that we want to take the position of object at different position. We want to consider the image formation at which position, in which position does the image is formed by considering the position of object at different places. Okay, so now we are going to look at each one. So first of all, we have said that image is the object is placed at infinity. Okay, the object is placed at infinity. Okay, then the position of the image formed will be at the focus. The position of image formed will be at the focus, and nature of image will be real, inverted and diminished. Real, inverted and diminished. It will be a point image. Okay, the image formed will be a point image. And let us look how the image is formed. So consider the first case. Here you can see that an image is placed at infinity. Okay, an image is placed at infinity, so that the light ray is coming and hitting the spherical mirror. Since these two rays are parallel to the principal axis, according to the rule, okay, these two rays are parallel to the principal axis. These are reflected back through the principal focus. Okay, these two rays are reflected back through the principal focus. So this is drawn here. So if the object is placed at infinity means it at a long distance. Okay, we can say it can be placed at an infinite position, then the rays will be hitting which is parallel to the principal axis. This is the principal axis, so it will be parallel to the principal axis. So the ray will be reflected back through the principal focus. Okay. So here the image is drawn. Since the image is reflected back through the principal focus, both the light rays are intersecting, okay, crossing each other at that point, so that there is only a point intersection, okay. So that what happens, so the image formed will be very small, and these are the real images since it is formed in front of the mirror. The image formed is in front of the mirror, so it is a real image, and it will be inverted image, okay. It will be inverted image, and it will be a small diminished image since it is a point, okay. So now let us move to the second position. Here we are going to place the object beyond C. Okay, this is the center of curvature. You can see this is the center of curvature. Okay, so that beyond C means this is the object AB. This is the object AB that has been placed beyond C. Then we can see how the image is formed. So here from the position A, the light may be passed through the mirror. Since it is parallel to the principal axis, it is reflected back through the principal focus. Okay, it is reflected back through the principal focus. Then you can say that there is also possibility for the ray passing through the principal focus. Okay, so the second ray will pass through the principal focus. So according to the law, if the incident ray is passing through the principal focus, it will be reflected parallel to the principal axis. It is reflected parallel to the principal axis. So it is reflecting back through a parallel position. So you can see this reflected light and this reflected light is intersecting at a point here. Okay, so that the upper position, we have taken the upper position A. So this intersection position will show the position A, the image of A. So the image will be formed here in an inverted position. Okay, the image formed here will be an inverted position, and the size will be less than that of the real object. Okay, so the image will be diminished, and since the image formed is inverted and it is formed in front of the mirror, okay, this is the mirror and this is formed in front of the mirror, so that it is a real image and it is inverted in nature and its size is less than that of the original object. Okay, so it is diminished in nature. So this is how we can draw the second. Then now we look at the third one. What means the object is placed at C. C means center of curvature. So the object is going to place at center of curvature, so that the image formed will be also at center of curvature. Okay, now let us see how the image is formed. Look here, we are placing the object at the center of curvature. This is the center of curvature C. Here you have been placing the object at the center of curvature. Then the light ray is going to be hit like this. Okay, first of all, it is parallel to the principal axis, so that what happened? Okay, so that it will reflect back through the principal focus. Okay, then what happened? Then it is a possibility for going through the principal focus, and if the ray is passing through the principal focus, then it will reflect back in a parallel to principal axis. It will reflect back in parallel to the principal axis. So this is the principal axis. So these are the reflected lights. So the reflected lights are meeting here. You can see the reflected lights are intersecting at the point A. Okay, so that the image formed is this. Okay, so that the image formed is here. That means it is at the same position of the center of curvature. Okay, this is the center of curvature. The intersection is taking place at the center of curvature. So if the object is placed at the center of curvature, image is also formed at the center of curvature itself, and that image is real because it is formed in front of the mirror. It is formed in front of the mirror, so it is a real image. Then it will be inverted image, and size will be same. Okay, size will be same as that of the object. The size of the image as well as size of the object will be same. Now let us see about the third one. Here, the fourth one, here we are going to place between F and C. Okay, F means principal focus and C means curvature. Okay, we are going to place that in between center of curvature and principal focus. You can see this is the object. We are going to place the object in between. Okay, we are going to place in between C and F. Okay, C and F. We are going to place the object. So let us see what will happen. We can say that the right ray will, first of all, the right light ray will pass parallel to the principal axis. Then it will pass through the principal focus. Then secondly, there is a possibility for moving through the principal focus. Then the reflected ray will be parallel to the principal axis. So the intersection is taking place at here. Okay, so the intersection is taking place there. So we can say that the image is formed here. Okay, so the inverted image is formed at this position, that is beyond C. C is here and it is obtained beyond C. Okay, beyond C the image is formed. Okay, so that what is the nature of the image? Since the image is formed in front of the mirror, it is a real image and it will be inverted in nature, as well as the size will be larger than that of the object. Okay, so that the enlarged image is formed here. So this is the image formation when we place the object in between center of curvature and principal focus. Okay, so this is the way we can identify. Now we can move to next one. We are going to place at principal focus. Okay, we are going to place at a principal focus. Okay, what happen if we place at principal focus? This is the principal focus F. Okay, we are going to place the object at F. So this first of all, there will be a light parallel to the principal axis hitting on it, and it will be reflected back through the principal focus. And secondly, there will be ray that will hit on the pole. Okay, here is a possibility for hitting on the pole. When hit at the pole, it will reflect with a same angle, isn't it? It will reflect it within a same angle. So this type of reflection is taking place. So what happened here? We can see that this is one of the reflected light and this is the another reflected light. And where does it is meeting? This is only meeting at a low position. Okay, so that the image is formed at infinity. This is known as infinity. Okay. So if we place an object at principal focus, the image is formed at infinity because the intersection is taking place at a infinite position. And what will be the nature of the image formed? It will be real because it is formed in front of the mirror, and it will be a inverted image. Okay, at infinity you can draw like this. If the principal focus is like this, principal axis is going like this, so that the intersection will be taking place at this point, and the image formed will be a very big enlarged, highly enlarged image, and the image will be inverted in nature. Okay, it will be a highly enlarged image and it will be inverted in nature. So the image is formed at infinity. This is happening in the case of if we place an object at a principal focus. Now we can move through to the next one. If we place the object at in between F and P. Okay, F and P. What happens when we place between F and P? Here you can see this is the F and this is the P. This is the pole. So F is the principal focus and P is the pole. So what happens when we place in between F and P? this is the object that we are going to place there. Okay. So, while we are placing there, there will be a reflection parallel to the line and it will be reflected back. Okay, it will be reflected back. It will be reflected back. Okay, then there is a possibility for hitting at the pole. Okay, hitting at the pole, it also reflected back. Okay. So, these two rays are going away. It does not meet each other. Okay. The image only forms when two lines get intersect. Okay. Here you can see it does not intersect with each other. They are going away. These two reflector rays are going away. So that what will the image will be formed. And the intersection will be taking place by the reflection like this. Here. Okay. So the reflection takes place here, so that the image is formed, intersection is taking place at inside the mirror. That means there is a formation of image inside the mirror. You can see that. So what happens? The formed image is enlarged image, and this image is a virtual image because the image is formed inside the mirror, not the outside the mirror. Okay, so that this is a virtual image. A virtual image is formed here, and it will be a erect. This is not an inverted image. This will be a erect image and will be enlarged in nature. So when we place in between F and P, we will get a image behind the mirror. This is mirror, this is behind the mirror, and this image will be virtual image, and also it will be enlarged erect image. So these are the various methods for identifying the image formation in concave mirror. Okay, these are the image formation in concave mirror.